Welcome back to the morning show. It's a Wednesday. That means it's Wise Guy time. Our Wise Guy is here. Matt Sellen, U of I physics professor. And Matt, thanks for coming in. The girls, thank you for bringing the Oreos.
Oh, yeah. Well, I'll show you in a moment what this is all about. But today's a very special day because it's basically, we're coming up on, well, first of all, it's a very special day because it's my wife's birthday. So I have to say happy birthday, Lynn. I love you.
Wow.
Okay. Now, it's also a special day because it's basically the second full moon in May, which is coming up. And this happens because the moon takes a little under 30 days to make its transit around to be the same relative position with the Earth every month or every cycle. And so in 29.5 days, after it's full, it's going to be full again.
Right.
So that's just under a month. And that means that if you happen to luck out and you have your full moon on the first day of the month, then you're going to get a second one basically on the last day of the month, and you're going to get two. And so depending on how you count, you could say that May has, you know, the blue moon, or June, or even July, because it doesn't move that much every month, but it's a kind of a rare occurrence. And so I thought I would use this as an excuse to describe how the phases of the moons work, okay? And so I have here, well, first of all, the baseball is supposed to give you the idea of how this blue thing is the Earth, really.
Okay.
It's not supposed to be the blue moon.
Pretty close, though. If you turn it right, it kind of looks like
the Earth, doesn't it?
North and South America.
And this baseball is sort of the size of the moon.
Okay.
Now, the moon is pretty far from the Earth. It's about 30 Earth radii. So if you stacked 30 of these balls next to each other, that's how far away the moon would really be from the Earth.
Okay.
But it still looks pretty big to us because it's lit up, and it has an effect on the Earth, as we'll talk about tides when we come back.
Okay.
Okay. But anyways, some people have kind of the wrong idea of what makes the moon have a crescent shape or a sort of a bulging shape and so on. And it's a very common misconception that it has to do with the Earth casting a shadow on the moon, but it's nothing like that at all. It really just has to do with how we on Earth look at the moon relative to where the sun happens to be.
Okay.
Okay? So now, if you look at the Earth from above, it sort of spins like this. It spins counterclockwise. And so suppose that we are this UPC symbol sitting right here, okay? And suppose we're looking this way. It turns like this, and then the left side of the UPC symbol sees the moon first. So we see the moon rising from, if we're looking south, we see things kind of starting from the left, working their way across and going to the right. The sun does the same thing. Okay, and so that's how we view the moon, and basically this lantern is going to be the sun, and what I'm going to do is you're going to be, the camera is going to be the observer on the Earth.
Okay.
And I'm just going to show you what the moon looks like for different positions of the sun relative to the moon, relative to the camera. Okay. So we're going to have to sort of dim the lights. I'm going to start right here.
Okay.
With a new moon. When the sun is kind of behind, like this, you don't see much. Actually, if you get out of the way a little bit and I move this way, otherwise we'll have an eclipse. Okay, so there we go. So now if you see what you see in the camera, if you kind of zoom in with on the moon,
right,
so you don't need to see the blue. There we go. So now you see this crescent moon.
Oh, okay.
And as I move around, you see that now you see this half moon. As I move around some more, the moon gets fatter and fatter. This is now called gibbous moon, and we have a full moon. It's very bright, and you have a very nice tie on, by the way.
Oh, thank you
over
very
there,
much.
And then it starts to sort of fade away again, and it becomes gibbous, and then we see a half moon, and then a little while later is a crescent moon, and then when the moon is sort of, or the sun is on the other side, then I'm just going to do it like this here. Well, it's a little hard for me. I'm going to do it so you can't see it. But okay, so you basically see it like that, and then as the new moon comes around, it's sort of, everything starts from the right-hand side of the moon and works its way to the left. So the new moon kind of starts on the right, which is where the left.
That's awesome. And great demonstration.
And what the Oreos are for, which is what you're probably really wondering.
You got about 20 seconds.
Okay,
can we wait till the next one?
Well, I'll just show you. You can use kids can use Oreos to basically make the phases of the moon, because if you leave all the cream, you get a full one.
I saw you brought Oreos and came back over there.
You eat half of the way, you get a half moon. So the assignment for you guys before the segment in 20 minutes is to make all the phases of the moon in Oreos.
All right, well, let's check in with Jennifer Ketchmark. Jennifer, can you do the